So we had talked about the early career of Renzo Piano in the first part of this lecture, and also about this partnership between Norman Foster and Richard Rogers called Team 4. And after Team 4's split, Rogers and Piano had worked on the Pompidou Center. Rogers came back to England and opened his own practice, as did Norman Foster. So I want to look at the two of them, their early careers, and then to look at two kind of high-tech monuments, which sounds like a contradiction in terms, but which will speak to the idea that these are not only kind of architectural experiments, but that they did actually have some pretty serious cultural relevance as well. After Rogers' partnership with Piano on the Pompidou, his early career is a little bit more, almost a little bit more science fiction than Piano's. He's very interested in component design and very interested in showing off the kind of fabricational elements of the building, maybe even more so than Piano, and doing it in a way that that really does look to kind of futurism, but also to the ongoing space missions, and to this, again, sense of science fiction that that society and culture in the future is going to be sort of technologically based. So here, an early proposal for a prefabricated house. And if you look closely, you can see not only are there windmills and anemometers and things like that, but the cladding of the house is made of fiberglass panels surrounding these floor-to-ceiling glass walls. And if you look closely, you can see that Rogers is looking ahead. There's even a plug-in electric car on the left. So not only is it the building, but it's a whole kind of lifestyle that Rogers is proposing here. When he gets actual commissions, he carries on this idea of almost sort of aggressively showing off the guts of the building, but also the way that the building is actually put together. So this early project, very much like Reliance Controls that Team 4 did, this is a project for a semiconductor factory outside of Princeton, New Jersey that the Richard Rogers partnership does in 1984. And you can see that all of the mechanical systems are not only on display, they are actually like elevated, right? They become the kind of roofscape of this project that is a long span factory that dispenses with any interior columns by supporting the roof from above by a tension structure and a mast structure that again allows the factory not only to lay out as it needs to, but to change with time. And so here you can see the fairly simple steel roof structure that's being held up by a system of tension rods and rings that basically sort of show off, almost like a Calder mobile, that show off the way the forces are actually balancing out. In section, you can see here that gives Rogers clear spans that the semiconductor processing can happen however it needs to, and a very, very clear layout of ductwork, right? The mechanical system is all contained within the masts above. There are these two distribution ducts that run the length of the building, and they feed smaller ducts that then have a sort of cross grain to them. Now, you could argue that this is an overly structured building, that there are probably much, much simpler ways to span the 80 or 90 feet that the roofs actually do. Rogers, though, is making the argument that the technology of the building, both its structure and its mechanical systems, are worth showing off. And so the skyline of the building, the kind of billboard or advertising for the building, if you like, is the way it's actually put together, right? The way that it actually stands up and the way that it actually functions. So is the structure more rhetorical than functional? Yes, probably. But this gets to this idea that high tech is not only about optimizing structure and environmental systems, it's also about that optimization, right? So the technology really becomes not only a method, but also a theme. Foster's kind of philosophy, by contrast, is one that benefits from his time with Buckminster Fuller. He works with Fuller on a number of projects in the 70s. Fuller comes on board really as a consultant and helps with this competition on the left for an underground theater at Oxford. And you can see that there are some space frames there that look vaguely geodesic. On the right, a domestic project that Foster designs for Fuller for a house that clearly is two geodesic domes, one inside the other, that allow for panels to open and close depending on what the weather is. There's some interesting ideas here beyond the geodesic dome, right? A double environmental skin, which we'll see come back in our lecture on sustainability. And you can see the triangulated structure of the floors within. And of course, one of the problems with the geodesic dome is how do you put flat floors in a spherical volume? And here you can see those details kind of ignored, right? The idea is more that you have a building within a building within a building. Foster goes for more a sense of clarity than Rogers. If Rogers is all about expressing every last detail, a kind of super empirical approach, Foster's is, I think, a little bit more true to Kahn's idea that all of those details have to build up into a legible concept that then governs everything else. So whereas Rogers' buildings are often kind of a riot of detail and color and components, Foster's are often much cleaner and much quieter in a way. They tell kind of one or two stories instead of thousands. One of Foster's earliest projects is one that is really the culmination of a century or more of glass technology. We talked about the move from cylinder glass to plate glass, and then how plate glass became industrialized in the early 20th century, and how Mises' glass skyscraper in 1922 was really a kind of a fantasy, right? That the glass technology was not there to do an all-glass skin as Mies wanted. Well, from 1972 to 1974, Foster Associates designed this three-story building in Ipswich, a small town northeast of London, for an insurance headquarters that has a lot of ideas about open plan workplace and amenities for workers. There is not only a swimming pool, as you see on the section, but the idea is that there will be a park on the roof. It's an early green roof on top of the concrete structure for the workers to have their lunch during a nice day. What's really come down to us in this building, though, is this skin, which is literally the first full deployment of a concept called structural glazing, developed in conjunction with Pilkington, who you may remember from some of the early advances in glass fabrication. Structural glazing takes advantage of the fact that if you treat it gently, glass is as strong in tension as steel, and therefore it is very capable of carrying its own weight over 2 or 3 or even 4 or 5 stories. The system that Foster's develops with Pilkington is a way to take each 3-story segment of glass and treat it basically like a giant tension column. So if you look at the detail here on the right, you can see that there is a pin that fits into an embed in the concrete curb. That pin is connected to a set of steel bars that basically takes the distributed load of the glass column, brings it back into the pin. The pin allows for a little bit of movement in 2 directions so that the glass is never put into bending. And from there, at the corners of each glass panel, there is a patch plate that connects each of the panes of glass to one another. And what this does is it means that the glass is continuous structurally from roof to street, but it also means that if one pane breaks, the load of the panes below it gets transferred to the glass around it. Back here, there's a glass fin connected to the patch plate, connected to the floor slab, that functions as the wind bracing for the glass from story to story. So 95% of the skin of this building is glass. The rest are just these small steel patch plates. And this is seen by critics as kind of finally fulfilling that Miesian idea of almost nothing, right? The curtain wall that completely disappears. And as you can see here, lets the interior of the building speak for itself, right? Quote unquote perfect transparency. This is a technology that becomes even more sophisticated as time goes on, but here all of the elements of structural glazing are in place for the first time. Foster's version of the museum, his sort of response or his sort of parallel project to the Pompidou, is the Sainsbury Center, which he does in 1973, which in some ways has some of the same themes, right? A vast open gallery that allows curators to move pieces around, to move partitions around, and a mechanical and lighting system that is equally flexible, that can adapt to whatever layouts the curators below are trying to put together. You can see, though, that Foster isn't interested so much in showing you every piece of ductwork. Instead, he's much more in Kahn's tradition of designating an adequate space for all of the services, letting you see where that space is, but not letting the visual chaos of all of these ducts, pipes, cables overwhelm the fundamental idea. And at Sainsbury Center, that fundamental idea is this clear space in the middle, this clear span that allows for a variety of gallery layouts and for those layouts to change. And as you can see here, Foster is showing off the structure instead of the services. So these long span trusses that allow that big span of something like 120 feet. At the same time, the openings in the truss allow for space not only for ductwork, registers, things that are going to feed the gallery with conditioned air, but also lighting and catwalks to adjust the lighting so that the museum staff can actually move things around without interfering with the floor below. In a very sort of Kahnian idea, when that truss comes down to the ground in this giant sort of portal frame, the depth of the vertical trusses contains all of the building services like bathrooms and coat check rooms, stairs up to the mechanical level and things like that. So there are two sort of opposite ideas here, right? Rogers is interested in showing all of the pieces of the building. Foster is more interested in designating areas for those, so organizing them in ways that allow for the primary expression of the building to really stand out. That's often a structural function, or it's often a programmatic function. Foster and Rogers both get a lot of press for these early projects, a lot of attention, and they both get massive commissions at the end of the 1970s that show both an incredible faith in young architects with what must seem at the time fairly radical ideas, but also the idea that big corporations recognize the sort of positivist story that's being told by these buildings, that any company that wants to be seen as technologically fluent, like remember IBM and Piano's Traveling Pavilion, these architects are natural kind of partners for developing an expression that's going to go along with that, right? A building that speaks to that level of technological fluency. So I want to look at two buildings, one by Foster, one by Rogers, that both sort of take these initial ideas and blow them up to absolutely massive scale and really make an impact, a lasting impact on how architects view the expressive potential of building technology, structure and otherwise. In Foster's case, that building is the headquarters for a bank in Hong Kong, the Hong Kong and Shanghai Bank. They hold an international competition in 1976, 1977. They solicit schemes from all the kind of big name architects. Foster gets in there because of buildings like Sainsbury. But it's important to note that the firm has never built above 3 stories before, so they've never done a skyscraper. And in the way the story gets told, that they use to their advantage. They decide that they're going to rethink the skyscraper from first principles. They are told by the bank that the site is the existing 1920s era structure. You can see that right here. And the idea is that the skyscraper is going to be phased to work around that, so that the building, even though it's not going to be kept, the banking hall is going to stay, the tower is going to be built around it, and then the banking hall can get demolished at the very end. Most of the other competitors build on different parts of the site. What Foster proposes is actually treating the building as a bridge, saving the banking hall, building the cores for structure, basically planking over the banking hall, hanging the office floors, and then when the banking hall disappears, using that space as a pedestrian mall that goes down to the harbor. And you can see here, there's the existing banking hall. Here are the cores, and there's a 50-meter span between that they say they will basically span using bridge engineering. You can see where it's going, right? That's the finished product. The irony is that the banking hall was actually demolished before the building was started, but the idea of the skyscraper as a bridge, as a set of suspended floors, was strong enough that the bank decided to go with it anyway. Foster's worked with Arabs to develop not only the first competition scheme that you see on the far left, trusses with literally hung floors below, and you can see that they're interested in the idea of opening sky gardens, double height spaces, triple height spaces to make sort of communities within the floor plates. And that gradually evolved to what were called the chevron schemes, the V shapes that represent tension elements that are holding up the center of the floors and letting the rest of the floors span between those center points and the towers on either side. The chevron, unfortunately, has bad feng shui. The bank decides it's a symbol of death, actually, the red V. And so they're forced, actually, by building tradition, to look at other schemes. And what they finally settle on is what they call the coat hanger scheme, where these towers on either side will hold smaller tension elements that then will suspend the floors from that. And as they're developing this, Foster's office does the drawing on the right, which shows, in this case, the chevron scheme in the lower right, up against other works where the structure becomes the architecture. So going back to the Eiffel Tower in the upper left, but also the Seagram's building in the upper center, Chicago's John Hancock Tower, second row. On the far right of the second row, the Alcoa building by SOM in San Francisco. You might recognize the First National or the Federal Reserve building in Minneapolis, the catenary cable-supported floors, Transamerica building, and the Pompidou Center. And what this poster basically is saying is that the Hong Kong Bank is going to become iconic in the way that it uses its structure as its architecture, right? The way that the structure becomes the architecture, very much as in the Eiffel Tower. The way that the building develops is as a series of kind of super columns made of vertical Vierendeel trusses that then support the tension arms of the coat hangers, which in turn support these vertical tension elements that hold the center of the floor up. And the structure is sort of complemented by the way the building is fabricated. Hong Kong has no native steel industry, and because it's a British colony, not Chinese yet, they can't rely on the direct use of Chinese steel. So they have to basically fabricate the building piecemeal in Japan, put every piece on a ship, and bring it into Hong Kong harbor, where it has to then get taken to the site and hoisted by crane. So the whole building has to get broken down into these relatively mobile components, right? Almost like Lego blocks. And Foster's designers basically use that as a way to explain the building, right? To have the building explain itself. The cladding of the building is designed to show off each individual piece and to give some idea of the sequence in which it must have been put together. Once that's all done, the planning of the building is also very clever. The cores are all pulled outboard of the structure so that on the inside, you can have clear spans as large as possible. And you can see here a typical lower floor on the left, upper floor on the right, where there is adequate access to the cores, both for elevators and toilet rooms, but also for fire safety, for fire stairs. And you can see the very, very large open floor spaces that result from this kind of tension idea, right? The coat hanger and tension rod ideas. The only interruption to the clear span, the 50-meter clear span, are those little tension rods, right? The little black circles in the center of the floor plate. On the floors themselves, they use one of the earliest forms of a raised access floor so that they can, much like Pompidou or much like Sainsbury, they can get into the floor and they can rewire it. This is before the computer revolution, but the building certainly benefits from that flexibility. You can see too that the floor depth changes, that once you get past the main spanning structure, the floor or the ceiling steps up in ways that bring in the maximum amount of daylight from either side. Because Hong Kong is tropical, because it's very near the equator, you want horizon light, you don't want direct light, and so you can see sunshades on both the north and south facades that are going to keep the direct sunlight off of that glass skin. And then on the right, you see the escalators, very famous ones at the bottom that come in off the plaza. The front door of the building is literally underneath where the original banking hall was. And then escalators are used throughout to join floors. And the idea is that people can move through the building more casually, can meet up with people more casually, and that there are these social spaces between kind of villages of floors that allow people some shaded outdoor space as well. On the right-hand section, you see the other thing that's kind of iconic are these window washing cranes that in a way that to me reads more like the kind of interest in detail and machinery that Rogers has, but nevertheless are kind of ornamental right there. Even though they're functional, they serve as the kind of ornamental top to the building. And within the bank itself, the main banking hall is in this giant atrium in the center of the lower floors. And to illuminate that space, they designed this great big sun scoop that literally cantilevers out from the side of the building, takes the almost vertical sunlight into the center of the building, and through a series of mirrors at the top, reflects it down into the banking hall and down to the plaza below. And on the right, you see the quote-unquote front door, these escalators that come through a glass underbelly and allow you to sort of rise up into the banking hall, into this cathedral-like space within. The building's assembly was, as I said, done on site, but with components that are all prefabricated in Japan, among other places. So here you can see a prefabricated bathroom. All of those tolerances inside are done in the factory, right? All of those details are done in the factory to very tight tolerances. So that is literally almost like a kind of automobile that's then put on a boat, raised into place and plugged in. You get the high finish, the very, very precise construction that you can get in a factory, but here on a giant skyscraper job site. And here you get a sense for the idea that the building is broken down into components, that each component is almost treated like an exercise in product design. The cladding, the fiberglass cladding, is made by Couples in St. Louis, so that's coming from a whole other continent, and wrapping each of these steel pieces. On the right, you see the sunshade, which is almost kind of an encyclopedia of techniques in aluminum. There are extrusions, there are castings, there are stamped elements, all that come together to create this very, very articulate sunshade on both sides of the building. And within, Hong Kong Bank is all what the British would call bespoke. So it is all custom designed. There are very, very few kind of off-the-rack components. A little bit ironic given the kind of early stance of high tech. If you think about the Reliance controls, there's a sort of joy in getting all the steel right out of the mill. Here, everything is custom designed, custom detailed, designed more like a car or a product than a typical skyscraper. And there are some nods here too, almost some Easter eggs if you like. The furniture is all Eames furniture. Eames is a huge influence, and the Eameses are heroes in the Foster office. And on the right, you see the composition, for instance, of the signage packages, right? Everything down to the doorknobs, down to the men's room sign, are all custom designed so that there is one aesthetic throughout. Again, in many ways, the kind of opposite to Rogers' approach. And Hong Kong Bank becomes truly iconic. It really sets Foster Associates up as an international practice. They go from a kind of regional firm that has only done a building 3 stories tall to being really one of the most influential firms on the planet. The bank itself, as you can see, shows up on Hong Kong's money, at least until the Chinese takeover in 1997. So that is about as iconic as you can get. And on the right, you see its presence on the skyline, right? This sort of very, very high design, very kind of quietly detailed, but nevertheless very articulate, very expressive building that becomes a part of the city skyline. And by standing out from buildings like you can see the 1920s bank right next to it, by standing out really makes the case for Hong Kong itself as a technologically savvy place. Even though the building is fabricated in Japan and the United States and brought to Hong Kong on ships, this is a real statement about the potential of technology not only to sort of energize a new type of workplace, a new type of civic monument, but also to become a legitimate form of aesthetic and architectural expression. In the last bit of the lecture, we'll look at the Rogers equivalent to Hong Kong Bank, and then we'll look a little bit at where the kind of context of high tech and some others who take the idea of technological expression in the 60s and 70s in slightly different directions.